Hello guys, so welcome again to my channel. So in today's tutorial we'll be talking about eNSP and the enterprise's network simulation platform in the field of open shortest path first about the OSPF configuration. So today we'll be discussing about how we can configure OSP. Now this is our topology. So this topology involves four subdivisions. We have the area 0, which is the middle area. This is the middle area. Then we have this area 1, we have the area 2, and the last area is area 3. So we will configure this topology using the OSPF. This is a protocol that we use to configure large networks. This is because if we use some strategy or some configuration like static for a large network, it will be inefficient. Some of the network or some of the subnets, let's assume each area belong to a different subnet. So if we use static to configure this topology, some of the route or some of the communication or some of the packets that we are sending through the topology may fail to reach the other end. So we prefer the OSPF, which is an open short path first, that it is simply look for the shortest paths possible within the topology. So this is how OSPF work. For those who have not idea of how this protocol work, it work by finding the shortest path within the network, and it uses that path to send packets. So how does it work exactly? So when we develop a network or when we develop a topology like this, so each router will send some hello packets. These hello packets, they are being sent within each router. We call it flooding. It floods to check if there is any router or any devices that has been connected or any nearly devices within it. So it sends a hello packets to every port that is being connected to look for a neighbor. So once these packets have been now sending, when another router receives it, then it responds back. Now it creating a connection in between, and they start sharing their link state advertisement. So the link state advertisement, later they request their details such as the router's ID and other things, and they install inside their link state database. So this information have been installed in each database to ensure that whenever we receive a packet or any information sending from one router to another, it will be able to know where to forward this packet and which is the relevant route to use. So without further ado, let's go ahead and configure our network. So another thing is that in today's video, as you can see, this is a large topology. It's an extremely large network. So there are some tasks that we will be minimizing to make sure at least this topology will work freely. There will be no complication. So I will try to make this video as short as possible by ensuring that I have already assigned some basic things like IP addresses to these devices. The only thing we'll configure with you is the interfaces, and also we will apply the OSPF configuration, but the IP addresses and other things I will do it by myself. Then we'll just need to copy. So let's go ahead and do so. So we will view our eNSP. So this is our eNSP. This is how this topology look like. So I have already configured the IP addresses within each devices. So the only thing has remained is to configure our interfaces in each router, and also we'll ensure that we have configured our OSPF protocol. So the main agenda here is how we can configure this open short path first protocol and to make sure we install it within our routers, so that if we try to send any packet from any area network, then this protocol will be able to find the shortest path as possible to forward that packets to, and to ensure that we are able to get reply. So we'll start by configuring our interfaces so that each router should be aware of each interfaces or each bound that is being connected to. So we'll start by configuring our interfaces, then later we will go ahead and configure the OSPF. So we start with this router 1 with an ID of 1.1.1.1 subnet mask of 32. So let's go ahead and do so. So as usual, system, we'll navigate to system name, and let's name this router as our first router R1. So we will be doing this for each router. Each router must be configured. Each interfaces will configure each interfaces. So since the network is out, the topology is too large, we'll configure some of these interfaces with you, then later I'll skip a little bit for the other, at least to save time and to make this video as short as possible. So we will configure this one and the main one here and the another one here, then you on your side you'll try to configure the remaining ones, then from there we'll start configure our OSPF. So let's go ahead and check for this interface. Let's go to interface Giga Ethernet 001. So just go to interface Giga Ethernet 0/0/1. Within this interface, let's assign an IP address of 192.168. It's within the .0 network, so .0. Then we are configuring this interface, so it's .1 with a subnet mask of 24. So the next thing, let's go ahead and configure this one again. So we'll repeat the process. Interface, this interface now will be, this interface here will be Giga Ethernet 00. So we'll go direct to Giga Ethernet 00. Then let's assign the IP address, which will be, it's within the .1 network, so .2 within the .2, so it's 2.2 within 2.2. So click enter and we are done with that part. So let's pick another one, this one here. Let's pick this one here within the area 0 and configure this one. As I said before, we will configure some, then the remaining one I'll be configured behind the scene so that to save time, then later we'll proceed from there. So let me configure this one once more. So system name. So this is the process, there's nothing has been changed. This is how we will be configuring our interfaces throughout. So let's come to this interface, which is Giga Ethernet 00. So interface Giga Ethernet 0/0/0. Let's assign an IP address of this IP address that is within this network, that is within the 6 network. So let's go ahead and do that. So IP address is 192.168.6. It's within the .1, so 1/subnet mask of 24, and we're done with that. Let's configure this also, Giga Ethernet 002. So Giga Ethernet 2 with an IP address of, it's within the .7 network, so .7, then the port is .2. Hit enter. The same for this one also. Go ahead and this Giga Ethernet 001 within the .8 network, so 001, and it's within the .8 network, so 8.3, and also we are good to go. So we have done configuring this one also. So let's go ahead and pick the last one. So this one is similar to this. So this one you'll configure this one. The interface is the same as this one, also the same as this one. So let me just pick the last one. Let me pick this one, and then we will configure these interfaces on your site also. So this one also, all of this, make sure you configure each router. So let's go ahead and configure this one. So go ahead and configure this. So system, then system name, then let's name this should be router 1 2 3. Let me call it router 4, and then let's go to this interface within the .8 network 000. So let's go to interface, let's go to interface G0/0/0. Within this interface the 8.2, so IP address is 192.168.8.2, subnet mask of 24. Let's do for this one again. This is within the Giga Ethernet port 3, so it's within 3 with an IP address of is within the .15 network, so 15.1, so 15.1. Then let's do the same for this Giga Ethernet 002 within the .14 network, so 002 within the .15 network, within the .14 network .3. Let's confirm it's Giga Ethernet 002 within the .14 network .3. It's good. So we are done configuring that. So I'll go ahead and configure the remaining one so that we can save time, and I'll get back to you. So let's configure the last one. So let's configure this last interface. So system name, this will be router 10. So this will be the last one. I'm configuring the last interface. So as you can see, all of the routers are now, their interfaces are now being configured. So let's go ahead and finish configuring the interfaces. So the interface Giga Ethernet 000, okay, 0/0/0, and we assign an IP address of 192.168. It's within the 14 network .2 with a subnet mask of 24. So hit enter. Now let's configure the inside one. So quit. So it's within the interface. This interface here is Giga Ethernet 001. Then the IP address for that interface is within the .17 network .1. So we are done configuring each interface. So the next task is now go ahead and start configuring our OSPF as I said earlier. So each router has now been configured. Each router has its own interfaces installed. Its router. Each router has been configured here. So the next thing we'll go is now we'll start configuring our OSPF. So for this one, we'll do it. This is the main agenda. So this will be doing both of us. So step by step until we finish. So from this, we will be proceeding to configure this OSPF and ensure that each router has an OSPF protocol installed in its own link state database system. So let's start by router with an ID 11. So just run it. Now let's start a system, and within a system let's write this code OSPF with a process 1. Then let's label our router. So our router ID is 1.1.1.1 and hit enter. So we are now telling the system that this is our information about this router. It has a router ID of 1.1.1 with a subnet mask of 32. So the next thing, we will be specifying the area. Where does this router lie? This router lie within the area network 1. So we will be specifying the router within this subnet network lie. So it lie within the area network 1. So we'll go ahead and specify the area within which our routers lie. So it lie within the router 1. So hit enter. Now the next thing we'll do, we'll go ahead and now assign these two interfaces using the OSPF protocol. So we'll go here ahead and write network, the network, this network, the network 192.168 dot this network dot 0 network dot 0.0 network. We are talking about this network here. This network is 0.0 network. So within this network we are expecting to have multiple or several IP addresses, at most 256 IP addresses. For the host are around 254. So the first one and the last addresses, the last one is used for broadcasting and the other one also, as we know, used for network. So is not assigned as host or as a valid addresses. So we will assign a subnet mask of 0.0.0.255. As you count from 0 to 255, that is around 256. As I said before, 256 addresses or IP addresses that are available within this network. So within the within the 0.0 network, we are expecting to have these addresses. So that's why we'll go ahead and specify our mask that the most valid addresses that will be within this topology is around 255. So that's why you're using 0.0.0.255. So we'll be using this whenever we have router that has been connected to multiple PC or to other available devices. But within router to router, we'll be using a strictly submask of subnet 32, which is 0.0.0.0, indicating that we only need that IP, that we only need 2 IP for the router, since we will be communicating from one router to another. So there's no need of having a lot of IP addresses that will be wasted. So we'll be using a strictly subnet mask. But for this one, we must specify this because we expect at the end of the day we might connect as many PC as possible within this router. That's why we have to specify the subnet mask of 0.0.0.255. So we'll go ahead and hit enter. And the next thing, we'll now specify this interface. This is the interface that we are talking about. This one we only need one IP addresses, so there's no need of having multiple IP addresses. So we'll go ahead and assign that one. So we'll go here ahead, we'll change this subnet mask to strictly 0.0.0.0, and the interface that we are talking about is within 2.2 network. So once done with that, hit enter and now proceed to the next one. So this will be what we'll be doing in each router. So we'll go ahead and do it one by one, step by step. So relax and let's proceed. So system, then OSPF processes 1, 92. About router ID. Our next router ID is 2.2.2.2. It's within which area? It's within area 1 again. So remember that So we must specify the area, so it's within the area 1. So it's within the area 1. So it's within the area 1. It's within the area 1. So the next thing we'll do, let's go ahead and assign the network. So the network, it's 192.168. We are talking of this network here. So 1.0 network, 10.0, then 0.0.0.255. Hit enter. So let's do it for the same one here, network. Then this one will be strictly, as I said before, then it's within 3.2. Hit enter. And also we are done with that. So let's come here. So here is the key point. So at this point, as you can check, this router has two interfaces. It is belong to area 1 and also belong to area 0. So this is what we have been talking about. This area serve in both area 1 and area 0. This is because each area must be connected to area 0. So every time we configure, every time we create any topology, there must be any connection or any topology or any subnet should be connected to area 0. That's why this acts as an interface. So it has two sides, which is they belong to the other. So one side belong to area 0 and the other belong to area 1. So we'll have to split these 2 points within the same router. You're telling that the router that this interface which belong to 6.4 network belong to area 0 and the other one belong to the area 1. So I'll go ahead here and let's start with the area 0. So we'll go ahead OSPF with the process 1. Let's name our router ID, which is 3.3.3. Now let's specify the area to which this interface. So we'll start by area 0. So go ahead and specify the area. So go ahead and specify the area. It's belong to area 0. Hit that tab. Now let's configure the network. So network is 192.168.6.4. so this is the network and it will be strictly, you only need the router IP address. So hit enter and you are good to go. So the second thing we'll do, we'll go back to area 1. So we'll go back to area 1. So we'll quit, specify the area, which is area 1. Now within area 1, let's go ahead and assign these networks. So go ahead here and assign network. So we assign network. The first network belong to 3.0 network, so it will be 3.3. Hit enter. The state neighbor file is complete, so go ahead and do the same. So do the same here. This now belong to 168, belong to 2.1. So 2.1. This one 2.1. Also hit enter. Now we are done with that part. So let's now go ahead and configure the next one. So we are done with this part. So we're doing the same for this. This what we'll be doing. So as you can see, it's the same strategy. You configure this one, you configure this one, and you configure this one. The same here. So let's go ahead and do for this one. So system OSPF, then process this one. Let's name our router ID, then which is 4.4.4.4. hit enter. Specify the area. This one belong to area 0. As you can see, it belong to area 0. So let's go ahead and specify the area and belong to area 0. And we have 3 interfaces within this area. We have 1, 2 and 3. So let's go ahead and assign the network. So the network for that point be 192.168. The first one belong to .6 network, then .1, and it is strictly. So that's the first one. Let's do it for the second and the third one. So let's go ahead and do for the third one. The other one belong to 7, the 7.7.2, and the last one belong to the 8.3. So this belong to 8.3 exactly, and hit enter. So we are done with that part too. So let's proceed and do the same for this one. So system, let's go to OSPF, the process one, specify the router ID as usual. The next thing we'll do is start with the router ID, which is 5.5.5. hit enter. Specify the area, as once again this belong to 2 area. It belong to area 1 and belong to area 0. So you must specify the both area within this within the router configuration. We must tell the router that we have 2 areas: the area 0 network, which is the which is the main area network, and the other one, which is the area 3. So specify the area. We now start with the area 0, and within the area 0, this is the network that belong to area 0. So we'll go ahead and configure it. So network, which is 192.168.7.1, and it is strictly. Hit enter. Let's do the same for this one and this one. So let's do the same for, so let's quit and let's now specify the area, the second area, which is the area 3. Within area 3, these are 2 networks that belong to area 3. So we'll go ahead and configure these 2. So network, so it's 9.2. hit enter. I'll do the same for this 10.3. So go ahead and do for the same one, which is 10.3. hit enter, and we are done with that part. So let's go ahead and do the same here. So the process is repeating. It's the same thing that we have been doing. So let me know in your comment section if maybe you want to, maybe there's something that you don't understand within this topology. I'll be there guiding you on how you can handle it. So feel free to comment, feel free to ask questions, just feel free to explain how the video quality is, how the design of explaining these topologies to you. So if it's hard to understand, don't feel free to comment, or even you can contact me via email. So it's good to be open. So let's proceed here. Let's try to finish this. So OSPF with a process 1. Let's name our router. So router ID is 6.6.6. It's within which area? It's within the area 3. So we'll go ahead and assign the area 3. So go ahead and assign the area. So it belongs to area 3. Hit enter. So these two interfaces, the interface that we're going to add within this network. So go ahead and assign network 192.168.9.3 strictly. Hit enter and do the same for this. So we'll do the same for this. So go ahead and do the same for this one, which is belong to 11.0. So 11.0 will change this because we are expecting more IP addresses, and hit enter. So we are done with that too. Now let's go ahead and configure this one. So as you can see, it's not that hard. It's about how you understand the procedure. So the procedure is too easy, but it's good to practice. So on your end, you can try to configure and see if you are able. So our router ID for this one is 7.7.7. It's within the same area, which is the area which belong to area 3. So the next thing, let's assign the network. So we'll go ahead and assign the network. So specify the network. And guys, kindly remember to subscribe to my channel. I'll highly appreciate for that. That one subscriber mean a lot to me. So help me boost my channel. So I will appreciate, guys. Also, it's good to comment, as I said before. Feel free to communicate. It's within the 10.2 network, and that it will be strictly hit enter. The next thing we'll do, it's within the 12 network dot 0 and we're expecting multiple IP addresses, so we'll use the subnet mask of 255. Hit enter and we are good to go. So 2 more steps and we will be done. So let's go ahead and do for this one. So let's go ahead and do for this one. So once we are done assigning or configure the OSPF protocol, we'll have to check the link state database for each router to check whether the state is full or whether it's now aware of its neighbor. So it must specify the neighbor which is connected to. So it must be aware of the neighbor that it has been connected to. So let's finish. So SPF process 1. The router has an router ID of 9.9.9.9. It's belong to which area? It belong to area 2. This one belong to area 2. So specify the area. So it belong to area 2. So So within the area 2, we'll go ahead and configure the network. So we'll configure the network here. Configure the network, which is 192.168. This network here, 16 belong to 16.0. Then with 0.0.0.255, we are expecting multiple IP addresses. Hit enter, and we'll do the same for the other one. We'll go ahead and this one also, which belong to the 15.2 and hit enter. So let's go ahead and do for this one. Also, we have to configure this one. I have to configure this one. I will not configure yet, so we'll go ahead and configure this. OSPF with a process 1 with a root ID of 8.8.8. So we'll specify the area. Also, it belongs to two areas. It belongs to the area 0 and also belong to area 2. So we'll go ahead and do that. So specify the area. It belongs to area 0. Let's start with area 0 and let us assign the area. This is the network that belongs to area 0, this one. So we'll go ahead and assign the network. Go ahead and assign the network, which is 192.168.8.2, and it's strictly, so we'll hit enter. We are done with that. So the next thing, we'll go ahead and assign this one that belongs to area 2. So quit. Now let's enter to area 2. We are now in area 2. Now let's configure these two networks here. So go ahead and configure the network. So go ahead and configure the network. The network that belong to 15. So the 15.1 network, hit enter. And the other one is 14.3 network. So we'll also do the same for this one. Go ahead and assign the 14.0 network, 14.3 also should be strictly, hit enter. So we are finished configuring that one. So the last one, we have only remained with the last one. So let's go ahead and configure it once more. So system, so OSPF with the process 1, the router ID, which is 10.10.10.10. This is our router ID. So let's specify the area. It belongs to area 2 once more. So it belongs to area 2. So now let's configure the network that belongs to this area. So go ahead and network. So the network is 192.168.17.0 network 0.0.0.255. As I said before, we're expecting some multiple other devices to be connected within that router. That's why we're specifying that mask of 255. Also, let's go ahead and do for the last within the .14 network. So we'll do this for the .14 network. So let's change this to be strictly. Then we'll go for .14 network .2, and we are good to go. So state is full. Now we will start check each one to know if each router is aware of its neighbor. So like this router here, we expecting it to has its neighbor as 8.8. So the next thing that each router will identify its neighbor by its router's ID. So this one will have an ID for this one, the same for this one will have an ID for this one, and this one, the same this one should have an ID for this, for the one that is within here, and the one for this. So let's go and check. So to check for to display our to check our status for IP routers, we use this command. So we simply use the display, we say display OSPF peer brief. We want to check the status of our router. So as you can see, as I said, this one, it is aware that there is another router with a router ID which is 8.8.8, which is this one. So the same one we are expecting for the others to have. This is good to check so that you will know if your system is now complete. It is aware if it can now able to forward packets to each destination that you will be specify. So let's check for this one too. And as I said before, for this one she must have an ID for this one, the .4. It's aware of this neighbor, the .9, and aware of .10 network. So as we have said, so as you can check this router here, so it's know its neighbor, so it should have detail for the neighbor that has surrounding it. So as you can check, it has a neighbor who is 4.4.4.4.4.4, which is this router. Also it has an idea of this router, which is the 9.9.9, and also the last one, which is this one. So any router that has been connected to its interface, it must install that detail on its link state database system. The same as we do here, if we try to configure the same or to run the same command here, we must be able to display the same information containing the detail for this router, detail for this router, and the detail for this router. So if you go ahead and display this one, also you can see it's aware of it's aware of all these routers. So it's aware of this router, which is the 5.5.5 routers. It's aware of 8.8.8, and also it's aware of 3.3.3. So these are neighbors. As you can check here, these are neighbor. It knows that there are these neighbors, and its state is full because it has already acquired information about each neighbor, and it has stored that information within its link state database. That's why you see the state is full. In case any of the neighboring router is not appeared, this means there might be a problem with there might be a problem that has existed during the configuration. So that's why I'm saying it's good to check the state of the router before even start pinging. This is because when you ping and you are not aware of how the router install this neighbor's information, maybe you might try to ping something and there's no response, ending up configuring something different that is not what you are thinking. So right now, if you configure a certain PC and maybe it's not pinging, we will be aware that the issue is not within the OSPF configuration, but the issue might be on the interfaces. So it will be easy for us to troubleshoot. But when you go ahead without even checking the state of each router, it will be hard for you to troubleshoot, or it will be hard for you to find the problem. This is because you might think that the problem is within the interface, and yet the problem is within the OSPF, somehow it's within the protocol that we have been trying to configure. So it's good sometimes to check so that you are sure of what you can configure or you can troubleshoot. So again, check the status. This router is aware of this router, which is the .1, is aware of .2, and also it's aware of 4.4 network, and their status as full. This telling you that this router 4 has its information about their neighbors. So it's aware that I have this neighbor who is a 4.4.4. I have its information and everything I want to know. So if I want to forward a packet from this area 1 to another area, I'll pass through this router with an ID 4.4, and then I will flooding or anything until I reach the point that I'm aiming to. So as well you can check for this one, but the main one are this one which are neighboring. Sometimes the main one to check if their status are correct. This is because within this one we can configure or we can troubleshoot easily than this one. So these are the main or the targeted points to check whether the state is full or that router is aware of its neighbor. So now we'll go ahead and try to pin. So we'll try to send some information, or we start to send some packets within the area within the each subnet and see if we can get reply. So as you can see also, this it has an aware of this neighbor. This is his neighbor, so it's aware of this neighbor. Also the same for this. So it's good to check. It's good sometimes to check so that you can be aware of what is going on. So let's try to come to this PC, the PC2, and try to run some command here to see whether we are able to configure this topology using the OSPF network. So let's try to pin. So another thing is that it's good to pin. Don't just pin direct from this point to this point. This is because we have said that the OSPF try to look for a shortest path as possible. So it's good to pin the points ama the main interfaces before reaching this point. If we try to pin it, it might lead to a system timeout or destination unreachable. This is because this router has not been able, this protocol that we are using is trying to look for this route so it will need some seconds to search for that path until it reach that point. So it might keep on failing, but later it will find the path and it will be able to give us reply. So it's good to pin each interface, at least each interface. Like this one is good to pin this interface, this one, then for this one. But it will depend on how faster the system is. So it can also pin this. We can try to pin this and we can be able to get reply. We don't know, but it's good to pin each interface or each area before reaching the area that we're trying to pin. So let's try to pin this PC here within the area 2 network. Let's try to pin this PC here. So we write its IP address, which is 192.168.17.3. So we are getting reply, but sometimes it might cause a system timeout or destination unreachable. This is because it's trying to search for that path before it reaches that destination. So it might end up, you might experience something that's of such kind on your side. So don't panic, provided that you have checked the system has already installed, the status are already full. Don't panic, try to pin each port or each next hop before reaching the destination. So we'll do the same for, let's try to pin the area 0 network. Let's try to pin this port here, which is 6.1, and also we are getting reply. So we are getting reply too. So this means that our topology or our network it's working good. So don't panic on your side if you experience some challenges. This is because the system is too large. So the protocol that you have installed, it need to find the path, and then whenever it get the path, it install on its IP routing table. So the next time you try to pin that destination, it will be easy and the reply will be fast. So let's try to pin this network here within the area 3 network. Let's try to pin this PC. This PC belongs to lof.3 network, and see if we can able to get reply. We are getting reply. So at that point we are good. So this is how, guys, you can configure any topology, any large network using the OSPF. We consider the OSPF as the good way for using when you want to communicate or when we want to send the data packet. This is because this method is flexible, it's dynamically, so as compared to static. As you can see, if you are using the static IP routing configuration here, it will take a lot of time. In case of anything that has changed, the system will not able to update itself, so it's tiresome. It need a lot of work. It need also you to be very keen, because if two things, or if you fail to configure one of the relevant information within the router, or if you fail to install a relevant information on the router, it will be hard for it to identify that path. So we prefer the open shortest path first as a protocol for using large networks, so to avoid the complexity. So this is how it's working. So I'll go ahead and also try to pin something from this side. Let's use this PC and try to pin anything from area 2 back to area 0. You can ping anything within area 0 or area 1. Let's go within this area 1. Let's try to ping something here. 168 dot, let's go 0. Let's go to 0 dot, let's say 3. And you see, as I said before, we have a request timeout. So this is what I was telling you. Our system, we might have configured our system very well, but it end up causing this request timeout. So we'll try to pin it multiple times to see if we are capable. So we'll do that by trying to ping each port or each interface before reaching this PC here that is within the 0.3 network. So let's go ahead and pin, let's pin this interface here 8.2. So 8.2, we are tracking the path. So up to that point we are getting reply. So let's go ahead and try to pin this one, this interface here within 2.1. So go ahead and do for 2.1. Also to that point we are getting reply. So as you can see, this path here up to this point we are getting reply. Let's now try to pin this interface here. So we'll be pinning the interface 0.1 to see if we are getting reply. Also we are getting reply. So up to this point we are getting reply. So let's now go ahead and try to pin the value that we were trying to pin before, the 0.3. This is what we are trying to pinging and we are not able to get reply. So you can see right now we are now able to get reply. So this is what I was saying. So you can, it's good to pin the interfaces of the next hop before pinning the actual destination to avoid that path misconfusion, or the OSPF is trying to find the shortest path as possible and it will take time. If maybe we try to trace, let's try to trace this route. Let's try to trace this route that have been used from this destination here, from this source here up to this destination. This is our targeted destination. Let's trace that route and we check the time it take to reach that point. So we are tracing this route to know which route has been used. So we'll go to with 192.168.0.3. let's trace this route. So this is the route. So we'll go step by step to check. So the first route, we use the first one, which uses the 63 microseconds. So total time of around 47. So it uses the .17 network. The .17 network. Why is the .17 network? This is the .17 network .1. So it uses this gateway. So from this point where we are trying to pinging, so at this point it goes through here and then it gets the data packets or being pass through this gateway. Also, if you can check our configuration, this is our main gateway. This is the gateway for this PC. That's why it has to start from that gateway. The next thing, if we check for .14 network, this is the path. So we can conclude that, as you can see, it's looking for a path. It's trying to looking or sending this data through the path. So let's go ahead and check. So dot 14 is this path, again around 78 microsecond. Dot 8, it come here to this point, again it go to dot 6. This is the dot 6 here. So I think I'm hoping you are able to follow. So it's good also to check on the side. Then it go to dot 2. This is the dot 2, and lastly it reaches to dot 0, dot 3, which is our destination. So this is the path. So this is the path that has been used up to this point. So thanks guys for your time. This is what I have for today. So thanks for your time. Hope to see you in the next videos. Please once again support my channel. It's new. Subscribe to my channel. Feel free to ask questions. Feel free to comment, guys. Hit that bell. Hit that like button. So thanks for your time. Thanks again, and it's good to remind you it's Kolo again behind the scenes. So see you in the next tutorial, and goodbye.